Hey guys, this is Steven from the Green Engineers, and welcome back to my Rule of Thumb series. So last month, I'm a little late for this month. I'm already into the next month, but this is actually for the month of May. We are now in June. Anyways, this in this video, we're going to be continuing kind of going over some mechanics of what we were talking about last month. So we were talking about the LiPo versus lithium ion last month. In this month, we're going to be talking about Inrunner versus Outrunner. Just checking this out. Ooh. Tiny Hoover. Anyways, yeah, sorry, that catch my eye. I had to look at it. Okay, so Inrunner versus Outrunner. This is kind of going to be impromptu video. I have not really set anything up. So let's go ahead and I was going to show you just some basic stuff about Inrunner versus Outrunner and how they how one is different than the other and how they and what the differences are and how one is better than the other at certain things. So basically, what I'm going to be talking about is the general applications of one or the other, and we're going to look at some specs and do some math to see kind of the benefits of each of one over the other. So first thing we're going to do is we're going to go on HobbyCam here because they have a lot of little like searching stuff that we could use to search for different motors and be able to compare them. So let's go ahead and do Inrunner by size and Outrunner by size. And what I will do to help you guys first start out, what is an Inrunner? So an Inrunner is, so basically you have this outer shell of the motor, and an Inrunner means that the stator, which is the part that rotates, is on the inside of the motor instead of on the outside. So in here you have the stator is the part that rotates. Let's look it up. Let's see if I can use. Let me see if I can show you here. Okay, well this is an Outrunner. Oops. Let me move this out of the way. Okay, so this is an Outrunner. So an Outrunner is generally what you're familiar with, where the stator is on the inside, and the outside, what's known as the bell, rotates, right? So the outside rotates, the inside stays stationary. And the inside is the one with the electromagnets, which are basically the winds of wire are the electromagnets. So this guy stays stationary, while the bell rotates on the outside, and the bell is lined with the permanent magnets. Now, on Inrunner, well, let's leave that over there. Let me see if I'll show you. So an Inrunner has a rotor. Oh, here you go. Full size image. Let's just use this one. Okay. So this is an Inrunner. The Inrunner, the stator. Same as stator. Stator is the part with the electromagnets. So the stator is on the outside, and the rotor, similar to the bell, the rotor has permanent magnets on it, is on the inside. So this has permanent magnets, this has electromagnets, but the rotor goes inside, and here you can see the stator is on the outside and the rotor is on the inside. So that's why they call it an Inrunner and an Outrunner. An Outrunner is the prop or the gear or box or whatever for car, boat, plane, helicopter, quadcopter, whatever. The outside is running the prop on an Outrunner because the bell, you're basically your prop or your motor or your gearbox or your tires or whatever are mounted to the bell, and the bell is spinning on the outside, while a Inrunner is the inside's running the prop, because the inside, the prop or whatever is attached to this shaft here, which is driven from the inside of the motor instead of the outside of the motor. So now, by physics, I will explain to you some of the basic concepts that you can take away from this of what benefits an Inrunner has over an Outrunner. So an Inrunner has a few basic benefits against the Outrunner. Number one, because the rotor is on the inside, you have a lot less of angular momentum, which basically means that you need a lot less force to increase the speed of rotation of the inside. Reason being is that the mass is concentrated way closer. So for the same exact size motor, so if they had the same exact outside dimensions, the rotor is going to have way less rotating mass on the inside than an Outrunner. Reason being is that the Outrunner, the outside rotates while the inside stays stationary, right? So, and on a similar size Outrunners to this guy, the inside may just be, the inside rotor may just be about that size. So you're talking, it's about a third of the size of the bell. So you're talking about a third of the diameter of the rotating part, or the running part. I'm going to call it the running part of the motor. So running part, again, Outrunner, the outside runs it. On an Inrunner, the inside runs it. So let me guys show you the equations for angular momentum here. Let's look up angular momentum. Do they have for a ring? So here's the important parts here. So angular momentum, where'd it go? Okay, so here, angular momentum and torque, how are they attached? Again, torque is force times distance. Force is equal to mass times acceleration. The rotation equivalent for point particles is IA. I is moment of inertia. A is acceleration plus 2 RP. So torque, or here torque, which is a force, is force with respect to rotation, is IA plus 2 RP. So IA is angular momentum times acceleration. So the larger the angular momentum, the more torque is required to get it to accelerate. So let's say that we got rid of that guy. Okay, here you go. Okay, so let's say that we just got rid of that guy. We just called that guy constant. This is angular velocity, right? W is angular velocity. So let's say we just got rid of that. So torque is equal to IA. So the larger the moment of inertia, if you were going to keep the same acceleration on both, so same acceleration, how much more torque are you going to need to accelerate the mass? So this stays the same, A stays the same, so we want to solve for torque. So if we have the bigger bell, without even, I'll tell you right now, without even needing to know the moment of inertia equation for it, is going to have a bigger moment of inertia. So the Outrunner is going to have a bigger moment of inertia versus the Inrunner, which is more tight and its mass is more concentrated. So when you have a more concentrated mass in the center, and versus on a ring, and a ring is even worse for a moment of inertia when it's all concentrated on the outside. So basically, if this is bigger for the Outrunner, that means that you're going to require more torque to keep the same angular acceleration. So it's going to require more torque to get it to accelerate. Versus an Inrunner with a smaller eye, you could have a larger amount of torque to get the same acceleration. So basically, what you'll get is it's more snappy. It's gonna accelerate quicker. So when you punch the throttle on your quadcopter, on your EDF jet, on your car, it's gonna increase its speed way faster than an Outrunner with way less torque. So it requires way less torque to accelerate this mass quicker because it's more concentrated. So basically, you could increase the speed. It's going to be more snappy. The Inrunner is going to be more punchy, more snappy. It's going to increase its speed very, very quickly. With that also being said, you're going to have less shake on the Inrunner because you don't have as much force on the outside. So with this guy, you're going to have, if there's any imbalance at all, and there was a problem in the manufacturer's balancing, and this Outrunner is very, very large, and you get a lot of vibrations, this motor is going to destroy itself way easier. While if you have a comparable size Inrunner, mass is really close to center, it's not going to destroy itself as much. So generally what that means, and that of course is proportional to the RPM, generally what that means is that you could rotate the Inrunner way faster than the Outrunner. So max RPM of an Outrunner extremely low compared to an Inrunner. So what that also means is that generally you're going to have a higher rating KV of an Inrunner versus an Outrunner. And we'll show you guys that in a second. But as well, because you don't have as big of a stator, because generally you don't have as big of a rotor for the same comparable size of the bell, so if you have the same exact, size motor, the Outrunner is probably going to have more torque, but the Inrunner is capable of way higher RPM, and I think that as far as the wattage, really beats out the what's it called? The Outrunner. Okay, so let's go ahead and look at some comparable sizes. We'll go size to size comparison. So here on the Inrunners, let's go to 25 to 34, and let's go here 22 to 27. Let's look for a 25. 25. And here you can see one of the main differences here is the amount of wattage that you can put into it because of that RPM speed. So here we have a 6S at a 22,000 kV motor with a max current of 80 amps and max power 1600 watts, 1.6 thousand watts. The high blade count will spin at 41,000 RPM and a low blade count will start at 46,000 RPM. The 4 poles, diameter 29 millimeters, shaft diameter, weight 174 grams. Also, another thing is it's generally the Inrunners are going to be lighter because of the weight of the bell and how many magnets you're going to need. Because the bell's on the outside, you're going to have way more distance to have to fill with magnets. So it's going to be filled with a lot more magnets than having aluminum housing on the outside. Anyways, Outrunner, let's look for 2845. Also, another thing that generally the Inrunners are going to be longer, a lot longer than the Outrunners because they want to get similar magnetic count as an Outrunner, so they're going to be longer. So let's actually go, if we're going to get something comparable, let's go ahead and decrease the length here and see if we could find something closer. Cause see here you see 20 by 40, 24. So what we could do, 20 by 30. Let's do this 20 by 30. So let's just, we're going to have to disregard the length because overall they're just going to be longer. That's just how it is. So let's look for something that is also 20 millimeter diameter of the rotor. Here's a 20-28. Okay, so this is close. This is close to the same exact size. Okay, so here's close to the same exact size, 20 by 28. It's 2 millimeters shorter. Okay, so this one, first let's look at the kV rating here. 5800 kV versus 1400 kV. So right there we can see the difference I was telling you about, the difference in the kV rating. So 5800 divided by, this one was 1400, right? Oops. 1400. So, almost the same exact motor size. The Inrunner is about 4.2 times the kV rating. Alright, so let's look at the power rating here. Idle current 2 amps, max amps 12. Voltage 2 to 4 cell. Well, this guy I believe is a 2 cell. So this guy's rated at 2 cell. No load current 1.2 amps. This one is less. Oh wow, 0.2 amps. Huh. So that's 6 times less. But then again, I don't know if these are tested the exact same way. Turns 20 turns, power 90 amps. So this guy is no load current. This guy doesn't really have much information, unfortunately. But that will right then show you the difference in the kV rating. Also, what I'm curious about, let's go back one more time. Let's look at the weight. Weight 22 grams. Wow, weight 49 grams. Interesting. So I might even be off with that. How the weight here, might 10 centimeters. They're about the same wires. So it must be that the material that it uses for the stator and how it makes the rotor are way heavier. But I think that will diminish the bigger size you go. Alright, so let's look further. Oh, this is a 2030, yes, that's a big motor. Let's look, see what else we have. Okay, so let's go slightly bigger then. Let's go, actually let's go 30 something to 34. Let's go this one, let's go this one. 2836 was actually a good looking one, but they're going to be way longer. So I mean, here's a comparable to that last one on that last page. $28.36. Okay, so here's a 2836. This is a 2845. It's quite a bit bigger. It's 9 millimeters longer, but let's just look at it. So weight 79 grams versus, I'm guessing this one's going to be heavier again. Yeah, this is 125 grams. So generally these guys are going to be heavier, even though it's a little bit longer. Max power 800 watts versus this guy 480 watts. Okay. This is a 2 to 3 cell. This guy's a 3 to 4 cell. So it looks like in general you're gonna have to run one cell lower than the Outrunner. Probably being that the Outrunner you're gonna get less RPM, more torque, so you don't have to worry about wrecking the bearings. While on this guy, if you go one cell higher, you're gonna put some damage on those bearings. Let's look at this 3100 kV versus even this one's even lower, even though it's not even the same height. Yeah, so this one's still lower even though it's not even the same size. And generally, if you go up in size, you're going to go up. You're going to go down in RPM. So this guy way higher wattage. Idle current 2.3. This one have that? No. So what's the other one I'm going to compare on here? Yeah, that doesn't really have anything else on there. Okay, so let's see what else we could find here. Oh, they're 2838. Oh. So here's 2838 versus 2836. So again, 2 millimeter difference. This one's rated at 600 amps, 600 watts, and this one's rated at 480 watts. And this one is a 3600 kV, and this one is a 2350. So quite a bit bigger kV rating. And what is this guy? This guy is 2 to 3 cell, and this is 3 to 4 cell, still about a cell lower. 95 grams versus, so just a little bit, this is just a little bit heavier. So I think that as you get larger, the Outrunners are going to get heavier. But one of the reasons why I think that is that the bigger it is, I guess you do have more magnets, but generally the bell doesn't have to get much bigger as far as the thickness of the wall. So the bigger it gets, it's not really increasing that much weight on the outside of the wall, but the bigger these get, the more solid the rotors are, and the heavier the rotors are. So I think from that is what is causing the Inrunners to generally be heavier. But I think on most applications, I would assume now that the Inrunners are going to be heavier. So still rated for a higher wattage, which means more power. It's probably going to be more RPM, obviously. So generally the Outrunners, if you have comparable size, same exact size, and 480 watts, and let's say it's rated, so if it's rated power at 408, it says max performance. So again, if you remember to my rule of thumb series on motors, you know that the max wattage is at 50% RPM. So at 50% RPM at the same size of battery, I'm going to assume that the Turnigy, this guy, the Outrunner, is going to have higher torque but less RPM, and the Inrunner is going to have higher RPM but less torque. Right? So another thing, obviously, that I wanted to get... actually, I'll talk about that at the end. We'll do some more comparisons first. Okay, so we've had two good comparisons where they are... One, Inrunner's heavier, higher RPM, but the Outrunner's more torque and lower weight. In one cell, you could run one cell higher. So I guess theoretically you could have slightly better efficiency because you're running at a higher voltage, and so you can run a lower amperage. And also they seem to have lower what's it called? Lower idle current, which is pretty weird. Alright, so let's look for another big one. Oops. Uh-oh. Let's look for a really, really big one. So this one is a 1600 watt S6S version. This is a 2857. And this is the 17, I think 17 magnets. 17L is number of magnets, I think. Okay, so we're not going to find something that's 57 millimeters long. Even the biggest ones, I don't think you're going to get anywhere near 57. Oh, we're getting closer. 50, 55. Okay, but that's huge. Yeah, I don't think we're going to find anything that's square. We looked at those. Oh, those are 3,000. Okay, so we might have found something that's a problem there. This is... This one we're looking for 36, 38, 36. Oh, 38? 28, 36. Oh, it's smaller, that's why. Oh, there you go. That's 3600. Okay, so here we have two options, and they are almost identical kV. So I guess you can get, you know, the same kV rating on both. But let's look at the impact it has on the cell rating. So here is 2836, and oh, it's 450 size Heli motor, and this is 3600. 450 size. This guy's rated at 3 to 4S. This guy's still rated at 2 to 3 cell. Max power 600 watts. Now this is 700 watts. This is 3700 kV. Is it still lighter? 70 grams versus 95 grams. Alright, so it looks here that we have found a chink in the Inrunner's armor. It seems that the size, comparable sizes, you can find an equal kV rating in a Outrunner that you can in an Inrunner. But that could just be how this one's made. It might just be the certain types of windings it has. Etc. So let's also talk a little bit about some other things that are equated to it. So, number one, we're kind of gonna end the conversation there. So each for the comparisons, you can find an Outrunner that has similar kV rating, has a higher wattage rating. This is a 600 watt versus a 700 watt, and a higher cell rating. So right now it looks like the brushless Outrunners are fighting, you know, pound for pound with the Inrunners. Now, another thing that the Inrunners have on the Outrunners, which isn't necessarily true for this guy. This guy is not true, because this guy is used for the exact thing that I'm going to mention that it is using it for, because it's using heli. So one of the things that Inrunners are very easy to do, pretty much every Inrunner will allow you to do, is to gear the motor. So because this guy is stationary, the outside housing is stationary, the inside rotates. It's very easy to bolt some sort of mount here, and then have a gear on here, and then have a stationary but rotating spur gear, so a spur to spur gear. While on an Outrunner, generally, I guess you could say it like this. Generally, this guy's stationary, but this whole thing rotates. The bell rotates with the shaft, right? So the whole thing's rotating. There's nothing really for you to bolt on unless you bolt on down here and you come up and you come over and then you attach. And then you have a spur to spur gear. Because this guy is rotating at the same speed that your prop or your gearbox or whatever's rotating. So in this case I'm talking about a prop. So that's difficult to work with. However, some of them, so that this same setup where it's pushed out through the top, this one is pushed out through the bottom. Now this you could use with the gearbox, because obviously it is. It's a heli motor, and pretty much all helis run on a gearbox setup. Now you think about it, most helis, I can say almost all of them, use Outrunners compared to Inrunners. So they are using this way where the shaft's pushed out through the bottom rather than coming out through the top. So now you have a spot where it's stationary and you can mount it, and then the shaft's going through, the shaft is rotating. So you could have a easy setup where this is mounted first to your frame, and then on the other side the bolts go through and attach to how you have your gearbox set up. So that's very, very interesting. So here, after this video, I mean, there's not much benefit over having an Inrunner versus an Outrunner, unless you could find that the Inrunner has way larger KV than what you could find. Also, another cool option is you could have water-cooled Inrunners, which is pretty cool. And that's another thing that I can't really equate for here is the cooling. And here you can see, like on this one's got an impeller design of the stator on the outside. So it's got an impeller on the inside there, and you can see inside the wrapping. So this guy will definitely stay cool, and you see that on some designs with some of the bell designs on like E-Maxes and stuff will have kind of that design on the bell. Anyways, so yeah, not really much benefit that I'm seeing over having an Inrunner versus an Outrunner. It's just that, but even if you have the same size Inrunner and Outrunner, you're still going to have the benefit of the snappiness of the Inrunner. So even though this has the same exact KV as this guy is going to still have a lot more snappiness to it. So if you're running something like an EDF, or you have really, really high load, the Inrunner is probably better for a EDF than the Outrunner. The Outrunner is going to have similar size and torque, a similar RPM, as well as torque here, as you can see, from a little bit more torque, same exact RPM, but a little bit more torque, because that's what equates to the extra difference in wattage. But the Inrunner is going to be snappier on increasing its speed, its RPM. So you're going to have more angular acceleration on an Inrunner than an Outrunner. So if you need something with snappy applications, such as an EDF where you're coming right towards the ground and you need that power right now, and you need to just put on the thrust really quickly, or you need something else that it spins very, very quickly, an Inrunner is probably the best option for you. So I'm going to be doing I'm eventually going to pick up some motors that are similar and do more testing on them individually as well to get a similar comparison as well. Alright, so this has been Steven from the Green Engineers. I'd like to thank you guys for watching my development video series. If you like this video, please subscribe for more videos like it. If you'd like to support my work, please check out the link in the description to my Patreon channel. And I will see you guys in the next video. Stay tuned for the month of June's Rule of Thumb series at the end of the month. And I thank you guys for watching. Take it easy. Peace.